Hi, welcome to this tutorial on Pythagoras' theorem. Now Pythagoras discovered a rule connecting the three lengths of a right angle triangle. This rule allows you to calculate one of the sides providing you know the other two sides. But before we start, we need to do something else, and that is learn the names of the sides of the right angle triangle. But first of all, the side opposite the right angle, okay, that's this side, is called the hypotenuse. So just write that in, the hypotenuse. And the hypotenuse is the longest side of a right angle triangle. You can see that this side is much longer than these two sides. So it seems appropriate to call these two sides here the two shorter sides. So we'll just write those in as the shorter sides. Okay? So we have the longest side, the hypotenuse, which is opposite the right angle, and the other two sides are called the shorter sides. Now, what did Pythagoras discover? Well, he discovered that the hypotenuse squared is equal to the sum of the squares of the other two shorter sides. And this is a theorem or rule that you should learn. Okay, so we'll just highlight that here. Okay, so make sure you learn this rule. So what I'm going to do now is just show you how it works. So suppose we have a right angle triangle. Alright, we'll just draw something like this. Okay, there's our triangle. We don't know it's right angled, but we do as long as we have that symbol in there. If it's not a right angled triangle, you cannot use Pythagoras' theorem. Well, let's just suppose that this length here is 8 centimeters and this side here is 5 centimeters. We have two sides of the triangle, and now it is possible to work out the length of this side here, which I'm going to call x. Alright. Now, this side here is the hypotenuse because it is opposite the right angle. Okay? And according to Pythagoras' theorem, the hypotenuse squared, so let's just write that in, that's x squared, is equal to the sum of the squares of the other two shorter sides. So these are the two shorter sides, so I can write 5 squared plus 8 squared. Now it wouldn't matter if I wrote 8 squared plus 5 squared, it would give me exactly the same result. Okay? So all I need to do now to work out x is to just solve this equation. So therefore, what I have is that x squared equals 5 squared, which is 5 times 5, which we know is 25, plus 8 squared, that's 8 8s, are 64. And if I add those two numbers together, 25 and 64, it comes to 89. Now to get x, what I need to do is to take the square root of both sides. The square root of x squared is x, and I'll just write in the symbol square root of 89 here. I'll need a calculator to work out the square root of 89, so if you work that out on a calculator, you should find that you get 9.433 and so on. So rounding this up to one decimal place gives x equals 9.4. Don't forget the units, which is centimeters, and don't forget to write in the approximation, in this case 1 decimal place. And it's always useful just to look at your answer and check to see if it makes sense. 9.4 centimeters is longer than the 5 and the 8 centimeters. Okay? Right, let's just try another example. So we'll just do another one here. Let's suppose we have, say, a triangle like this. Remember, it must be a right angle triangle. So we've got a right angle in here. And let's suppose that this length here is 6 meters and this length here is 3 meters, and we're asked to find this length over here, x. Okay, now in this triangle, where is the hypotenuse? Well, the hypotenuse is the side opposite the right angle. So that would be this side over here, the 6 meters. So according to Pythagoras' theorem, okay, the hypotenuse squared, that's this side here, 6 squared is equal to the sum of the squares of the other two shorter sides, and these two sides are the shorter sides. So I can write equals x squared plus 3 squared. So you've got to be very careful in this example that you do not start with x squared. Okay, x squared does not equal 6 squared plus 3 squared. Okay, all I need to do now is just rearrange this equation, and to rearrange it I could subtract 3 squared from both sides. So therefore what I'm going to have is x squared is equal to 6 squared minus 3 squared. So again you can see that in this example we had x squared equals 5 squared plus 8 squared when x was the hypotenuse, but when x was a shorter side, not the hypotenuse, x squared turns out to be the hypotenuse squared minus the other shorter side squared. Okay, so all I need to do now is just work this out. So we therefore have x squared equals 6 squared, that's 6 times 6, which is 36. Take away 3 squared, 3 threes are 9. And so 36 minus 9 is 27, so x squared equals 27. And now I just need to square root both sides. So the square root of x squared is x, and the square root of 27 we'll just write in like that. So using a calculator, we therefore have the square root of 27 is 5.196 and so on. And so therefore, rounding this say to 1 decimal place, we have x equals 5.2 meters. And don't forget to write the 1 decimal place in. Okay, so we have 2 examples here. Okay, the first example was about finding the hypotenuse, so we'll just write this in here, finding the hypotenuse. And when you find the hypotenuse, remember that x squared, the hypotenuse squared, equals the sum of the squares of the other two shorter sides. But in this example, what we were doing was not finding the hypotenuse, but finding a shorter side. So just squeeze that in there, finding a shorter side. And so you've got to be very careful with this type of example. Remember, the hypotenuse squared equals the sum of the squares of the two shorter sides, or you could start with x squared, but remember, x squared equals the hypotenuse squared minus a shorter side squared. Okay, so hopefully using these 2 examples now, you should be able to work out any side of a right angle triangle, providing you know the other 2 sides by using Pythagoras' theorem.